Good afternoon. Join ಆಗ್ತಿದ್ದಾರಾ? We talk about probability distributions today. In the last class, we understood the definition of probability, and we'll be looking into some of the problems. From next week onwards, your offline classes starts. So we'll be solving much of the practical oriented questions and numerical problems there. So we'll talk about probability distribution. We are very much familiar with the concept of frequency distribution, an arrangement of the values taken by the variable along with the frequency. Now here we talk about the variable called as a random variable. The first definition under the section is random variable. It is defined as a function from sample space to real life. So remember, probabilities are observed from the sample space. So you have a sample space from which you are trying to obtain the probability of happening of an event. Now, from the outcomes of the experiment, which is a particular outcome, we are trying to convert that outcome, and we are coming with the mathematical technique so that the outcomes could be written in terms of real numbers. Now that mathematical function f of x, which transforms the sample space into real line, that is called as a random variable. So this function is called as a random variable. So you can take an example. So if I toss two coins once, then the possible outcomes are both might show head, or first one head, second one tail, first one tail, second one head, or both tails. Now you define an f of x, which we generally indicate by x, such that each of this symbol gets converted into some numbers. So I can say that in this experiment of tossing the coins, I'll observe these four possible outcomes. Of these outcomes, I'm interested in counting number of heads. So you have S, which has HH, HT, TH, and TT. If I say X is the number of heads I'm counting, in the first case, the value is 2. Both are showing heads. In the second and third case, it is 1. And in the last case, there are no heads, so the number of heads is 0. So you're converting the sample space, the elements in the sample space, into real numbers like this. So this function, x is equal to number of heads, is called as random variable. Why it is called as random? Because it is based on the random outcome of the experiment. So whenever you toss two coins, and if you say what are the possible values for number of heads, it takes only three possible values, 0, 1, 2, and there are two cases where one can happen. So it could be HH, or it could be from HT and TH. So when you look into the type of mapping we are interested here, you can have a case where two or more elements of the sample space will have the same real number, but the opposite cannot happen. So you cannot have a case where two different real numbers will be mapped to the same item. Two different real numbers will be mapped to the same item. So this cannot happen. So that is the condition put on the real number. Whereas two different elements from the sample space, they can take the same possible real number. So this is the condition put on the function. Now you might say, instead of using number of heads, can I model it using some other definition? Definitely. You can define y as number of tails, and instead of counting the number of heads in the outcome, you're counting the number of tails. Then this is 0, 0. This is equal to 1. This becomes 2. So even the number of tails, the possible number for this is 0, 1, 2, etc. Sorry, 0, 1, and 2. Now, similarly, if you expand this experiment into 3 coins, 4 coins, and so on, you can easily generate the values of x. X is equal to 0, 1, 2, 3, where you define x as number of heads or number of tails when 3 coins are tossed. Similarly, when 4 coins are tossed. So we have somehow converted S into x. Now we should look into the probabilities of x. Using the mathematical definition, we know what are the probabilities. So I have outcome of the experiment. So experiment is tossing of, let me take 3 coins, and then I'm defining my x as number of heads. And we just saw that if I toss 2 coins, the possible values for x is 0, 1, 2. So if I toss 3 coins and count what are the possible number of heads when I toss 3 coins together simultaneously, I could have no heads, which is x is equal to 0, or 1 head, 2 head, and 3 head. And we know the sample space for the experiment. And if you remember that sample space had 8 elements, HHH, HHT, HTH, HTT, and then THH, THT, TH, and TT. So these are the 8 cases, and we know how to compute the probabilities. If I say E1, probability of event E1 is equal to getting 2 heads, then you will write the set E1. What are all the cases of these 8 which are favorable to exactly 2 heads? So I have a case where I have 2 heads here, here, and here. So HHT, HTH, and THH are the 3 cases out of 8. So I have number of elements, that is n of E1 is equal to 3, n of S is equal to 8, therefore probability comes to 3 by 8, which is 0.125. So this is what we have learned in the previous class. Now instead of writing the probability for events, now we write the probabilities for the x, which is the random variable. Now the same concept, if you feel difficulty, you can write what are the favorable cases for this, count how many are there, and write the probabilities. Now to just for the first problem, I'll just write those cases. So when I say x is equal to number of heads, that means you are talking about an event E1 which is equal to no heads. So talking about an event where E1 is equal to no heads, and there is only one favorable outcome for no heads out of these 8, which is TTT. Therefore, P of E1. So while writing the probability, in this case, we wrote it as P of E1. Now, our E1 is same as my x is equal to 0. So we write P of x equals 0 is equal to 1 divided by 8. So P of x is equal to x, to be precise. So this is the notation where capital X indicates the definition of the variable. Small x indicates at that particular time what is the value taken by the variable. So here my small x is 0. In this case, small x is 1, small x is 2, small x is 3. What is capital X? Capital X is 0, 1, 2, 3. All possible values, or it is the definition of the random variable. Now, in the next case, if I say what are the cases where my x is equal to 1? X is equal to 1 indicates number of heads is equal to 1. So you're talking about 1 head. So you have 3 cases, HTT, THT, and TT. So you can call this as event 2, which exactly equal to 1 heads. So have HTT, THT, and TTH. So I have 3 cases. So n of E2 is equal to 3 and n of S is equal to 8. So P of E2 is equal to 3 by 8. So this is 0.125. This is 0.375. Okay. And the next case, we are talking about next event where I say x is equal to 2. X is equal to 2 indicates the event of happening of exactly 2 heads. So we have already taken and computed what is the probability for 2 heads. So this is my case, which is HHT, HTH, and THH. So I have 3 cases. So probability will be equal to 3 by 8 again, which is 0.375. And the last case where x is equal to 3, I can take that as event E4, where all the 3 cases of head happens, and that is only one particular outcome. So the probability for x is equal to 3 is 1 by 8 or 0.125. So this is how you will use the knowledge of sample space and event in writing the distribution. Now, whenever we say write the distribution of a particular random variable, then these prior things in detail, they are not necessary. So let me define x is equal to number of heads observed when 2 coins are tossed. So you should be able to write the probability distribution without hesitation. So 3 coins are tossed. So I have the x values are 0, 1, 2, 3. I know the sample space. So just count and write the probabilities. So for x equals 0, it is 1 by 8. For x equals 1 and 2, it is 3 by 8. X equals 3, it is 1 by 8. Either you can keep it in fraction or you can replace them by the decimal form. If you have correctly obtained the probability distribution for all possible values of x, under the definition, then your total probability, where total probability is indicated by sigma p of x is equal to x, you will observe that that comes to be exactly equal to 1. And this is an example of probability distribution. So what is a probability distribution? The arrangement of values taken by the variable. Arrangement of values taken by the variable. All possible values taken by the random variable along with its probability. You can just simply call it as P, or you can call it as Px with capital X or with small x. Okay, all the notations are valid. So such a tabular form representation of x and p values is called as probability distribution. Now, once we have a probability distribution, we can obtain the value of mean, median, mode, variance, standard deviation, and all the measures like skewness, kurtosis, mean deviation, quartiles, quartile deviations, everything are well defined even for a probability distribution. But of those possible measures, we only talk about 2 important measures, which are mean and variance of a distribution. The concept is quite same as that of frequency distribution. And if you look into the relation between frequency and probability, so in the second definition, I said our probability is nothing but the relative frequency. So divide every frequency by n and you can take those R values as probability. So if you are computing arithmetic mean, in this case, in the frequency case, we saw that the formula is sigma fx divided by sigma f, which is nothing but capital N. Now since n is constant here and f by n is defined as p, now you can see that if you send n inside, you can have this arithmetic mean formula as sigma f by n into x. And if you replace this f by n by probability, you will observe that it is p into x. Now sometimes px, this notation might be confused with p into x. So we write x first and then p, indicating that this is the mean of the distribution. So to obtain the mean of a probability distribution, you have to just multiply x with the respective probability and then take the total. So in this case, you have p values like this. So multiply x and p. So we'll have 0 into 0.125, 1 into 0.375, 2 into 0.375, and then 3 into 0.375. And if you look into the total comes to be 1.5. So what is this telling is that if you are, trying and tossing 3 coins once, then on an average, you will expect 1.5 heads. But practically that is not true. You cannot have a case where you're tossing 3 coins. You cannot really observe 1.5 heads, but that is average. And average speaks not just about one particular trial or one particular value of x. It is for a set of values. So what is this telling is that if you repeatedly, obey or conduct this experiment tossing 3 coins and count how many times you have got or make a frequency distribution for number of heads. And from the frequency distribution, if you compute heads, number of heads. Yeah, Vasant Kumar, shall I remove you? ಏನು ಎಲ್ರು ಬಂದ್ಬಿಟ್ಟಿದ್ದೀರಾ ಕ್ಲಾಸ್ಗೆ? ಟೆಸ್ಟ್ ಕೊಡಲ್ಲ ಅಂದ ತಕ್ಷಣ ಇವಾಗ ಏನೋ ಜ್ಞಾನೋದಯ ಆಯ್ತಾ ಕ್ಲಾಸ್ ಕೇಳಬೇಕಂತ? So this average are not for a particular case, they are for a long period of time. So this is the main. So we have just observed the simple form of arithmetic mean for a probability distribution. So we can now just see what happens to the mean. So we define what called as mathematical expectation. So as just said, average is what you are expecting in the long run. So we can not only expect what is happening with respect to x, we can just define it for a simple function of the random variable. So we are talking about simple function. So let me say I have the function g of x, then mathematical expectation of that g of x is denoted or indicated by this E for expectation, and it is read as expectation of g of x, and that is defined as the total of the product of g of x with the respective probabilities. So multiply the probabilities with g of x, and then you can obtain the total of that. That total is called as mathematical expectation of g of x. So this is read as mathematical expectation of g of x. Now we talk about two simple cases here. So you can take g of x to be anything. It could be x, x square, x cube, 1 by x, log x, any other function, sin x, cos x, any continuous function which is well defined on x could be taken as g of x. Now you can see the similarity. If you take g of x as x, it produces the form e of x, which is equal to the value of mean. So case 1, if g of x is equal to x, then I get e of g of x is equal to e of x, which is nothing but total of, in place of g of x, I'll just have x, and then p of x is equal to x. Or simply, as said, if you have problem in writing this large notation for the probability, you can simply call it as p. So if you obtain the total of x into p, then that becomes the mean of the distribution. So you can have a question which says, what is mathematical expectation? Then this is the definition. Mathematical expectation is defined for a function. So this g of x is a function of random variable x. For that function, the expectation is defined, and this is the formula for mean. So ಇಷ್ಟನ್ನ ಅರ್ಥ ಇಟ್ಕೊಂಡ್ರೆ ಸಾಕು. E of x is equal to total of x into p. P of x or total of x into p. That is mean. Now to obtain variance, we need the expectation for x square also. Because if you remember the formula for variance, variance is defined as sigma fx square by n minus x bar square. And we are indicating mean by e of x. So whenever you are talking about the mean of a probability distribution, don't just call it as x bar, write it as e of x. It is read as expectation of x. For a frequency distribution, your mean is indicated by x bar. So this f by n becomes your p. So it is sigma x square into p, and our x bar square is nothing but e of x square. So it is e of x, that is the mean square. And if you look into the expectation of g of x, which we just defined, expectation of g of x is defined as g of x into probability and its total. Now you can see the similarity. In place of g of x, you just have x square. So this can be written as e of x square. This is the formula for variance. So to obtain variance, so first you have to compute mean e of x and then compute e of x square. What is e of x square? E of x square is total of x square multiplied by the respective probabilities. Or simply you can just say x square into p. Once you have that, then you can say variance. And variance for a random variable x is indicated by v of x, where v of x is equal to e of x square minus e of x whole square. Okay, so please look into the square term. This is expectation of x square. What is expectation of x square? You're squaring every value of x, you're multiplying that with p and then taking the total. E of x whole square, e of x is mean, which is just the sum product of xp. And then after computing the mean, you're taking the square of that and then you're using it for the calculation of variance. So this is the formula of variance which you have to by heart. So we need e of x square, and variance of x formulas. So memorize these three forms. In the examination, you can have a problem where a probability distribution will be given and you have to obtain the mean of that particular distribution. I think I had given you a homework to write the sample space when 4 coins are tossed. Have you written? Have you done? You try. Number of heads when 4 coins are tossed. Madadra. Can you tell me what will be the sample space or how many elements are there in the sample space? When I toss a coin 4 times or when I toss 4 coins once, what are the different possible outcomes? Or how many different possible outcomes are there? Can speak. ಮಾತಾಡ್ಸ್ವಾಗ ಮಾತಾಡಬೇಡಿ, ಬಾಕಿ ಟೈಮಲ್ಲಿ ಗಲಾಟೆ ಮಾಡಿ.
So 16 times.
Yes.
16.
16 different possible outcomes. It is very easy to generate them. So you just, observe it as outcome of 4 different coins. So you have coin 1, coin 2, coin 3, coin 4. So all could show head. So this is one case. Now in order to cover all those, 16 values logically, you just increase or change the outcome of a coin one by one. So first you will just change the outcome of the 4th coin, keep all same. Then change the outcome of just the 2nd coin, keep the remaining same. Then change the outcome of the 2nd coin and 4th coin. Then these are the cases, or I could simply just say interchange these two. Inno easyagi helbeku antandre there are 16 cases in total, so you divide those cases as 8 by 8. You divide those cases as 8 by 8 cases, 8 and 8. So have coin 1, coin 2, coin 3, coin 4. Now first for the coin, you know that there will be 50% times of head and 50% times tails. So your coin may have head for these 8 cases. 1, 2, 3, 4, 5, 6, 7, 8. And then for the next 8 cases, it will take tail. So we're done with coin 1. Next, coin 2 will have again 8 heads and 8 tails. Now these 8 heads could come with the heads of this as well as the tails of this. So you will give 4 heads for these head and 4 heads for the tail. And then bring in the tails. So it is very easy. 8, 8, 4, 4, 4, 4, then 2, 2 each, and then 1 each. So I'll have HT, 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 HT. So this is how, using this method, you can write the sample space for even 5 coins, 6 coins, and so on. But that is not required because in the coming session, I'll give you a mathematical form which helps you in computing the probabilities easily without even looking into the sample space. Now, this is the distribution. So the question could be like this: obtain the mean and variance. Obtain the mean and variance of distribution x is equal to number of heads when 4 coins are tossed. So you know that whenever you are tossing 4 coins, if you look into the variable number of heads, so in each section, see how many heads are there in all those 16 cases. You can see that the maximum it is 4, minimum it is 0, and it is in between 0 to 4, but it takes only integer value. So the possible values are x is equal to 0, 1, 2, 3, and there are a total of 16 cases. So the denominator of every probability will be divided by 16. Now see what are the cases for 0 heads. 0 heads can happen in only one case, which is tail, that is 1 by 16. 1 head can also happen in the same case, which is 1 by 16. I mean 4 heads. Next, coming to the case of 1 heads. So highlight the cases where you have only 1 head possibility. So you have a case with one head here, HTTT, and then here 2, here 3, okay, so that's 3 by 16. So similarly, 3 heads
Sir,
indicate
THTT. One more is there.
THTT, yeah. So that's case of 4. And if you look into the case where you have again 3 heads, it will be same as that count. So can easily check that 3 heads here, 1, 2, and then 3, and then 4. So the remaining cases will be the case with exactly 2 heads. So the total comes to 16 by 6. So this is the probability distribution. Question says obtain the mean and variance. So we know that formula mean is equal to E of x. Mean is equal to E of x, which is total of x into probability. So we have x values, we have probability values. So just multiply them. So x into p. So I'll have 0, 1 into 4 by 16. Can convert them into decimal numbers. Not an issue. And 4 by 16 and obtain the total of x3. So this comes out to be 32 by 16, which is equal to 2. So this is the mean. Now to obtain variance, first step is I need E of x square. So E of x is done. I need E of x square. Only then I can calculate the value of variance. Now E of x square is nothing but total of x squared into p. So first compute the square of every value of x and then multiply that by p. So we have x value 0, 1, 2, 3, 4, 0, 1, 4, 9, 16. I multiply this with the respective probability. So P of X, I'm just simply calling it or indicating it by P. 0, then 1 into 4 by 16, then I have 4 into 6, 24 by 16, 9 into 4, 36 by 16, 16 into 1, 16 by 16. So the total of x squared p comes to be 30, 40, 50, 60, 70, 80 by 60. So we have p of x squared is equal to total of x squared p, which is equal to 80 by 60, which is equal to 5. Is that correct? 30, 40, 50, 60, 70, 80, 16 times 80. So variance V of x is equal to P of x squared minus P of x the whole square. So we'll have variance as expectation of x squared is 5 and mean is equal to 2. So it is 5 minus 2 square, 5 minus 4, which is equal to 1. So the variance is equal to 1. I could have a case where in the question, these are very simple problems, tossing 2 coins, 3 coins, or similarly, you can have a problem with throw of a dice and counting a particular sum. You can write the distribution for that always, can obtain the mean and variance. So to compute that, necessarily you need the information on x and y. Now, sometimes in case of coin experiment like this, they will not give you x and p. You have to compute x and p. In some cases where a problem is a variable is not just easy to observe and compute, in those cases they will give you the value of some x and p, and then you have to obtain the distribution. So let me say I have a random variable which takes values -2, -1, 0, 1, 2, and then it takes probabilities say 0.3, 0.2, 0.1, 0.05, and 0.35. Not 3, 4, 5, 6, 7, 8, 9, 10, such that the total probability is equal to 1. So if x and p a distribution is given to you like this, and the question says obtain mean and variance, and you compute 3 columns, x into p, x square into p. Look into the total of x square p, total of xp, obtain mean e of x square, and variance. Okay, is it clear? Any questions or doubts here? So this is how we obtain a probability distribution from the experiment. And the probability distributions, what we just obtained, these 2 cases are called as probability mass functions, because here my variable is discrete variable. So discrete variable, it means that it takes only some specific values. So we could easily observe what is the exact number of heads in the experiment. And such distributions are called as probability mass function. The reason is that the total probability is equal to 1. So if any distribution is such that the total probability is not equal to 1, then it just serves as a probability distribution, but not a probability mass function. So these are the necessary and sufficient conditions to check whether a probability distribution, conditions for a probability distribution to be probability mass function. And in short, we call this probability mass function by PMF. So if you have any probability distribution such that your x values are discrete and the total probability is equal to 1, then such probability distributions are called as PMF. For example, so we have just looked into 2 such PMFs. So I had x is equal to number of heads when 3 coins are tossed. So the probabilities are 0.125, 0.375, 0.375, and 0.125. You can see total probability is equal to 1. And if you look into individual probability, those must also be greater than or equal to 0. In case of discrete case, this need not be a condition to be verified, because by the definition of probability, we have said probability for a discrete variable is such that it lies between 0 and 1. So this, at the times need not be verified. Yes, so this is a PMF. Why? Because your total probability is coming to be equal to 1. So you can have a case where the distribution, you have a probability distribution, but it is not a PMF. You could have a case like this, which is one level value. Let me take 3 and 0.05. So your total probability comes to be 0.95, which indicates that you're missing out some of the outcomes in the experiment, or missing some values of x. So there is a chance that 0.05 of chance that something else is happening with this x. So you are not completely observing that. So that is a case where your distribution is not a PMF. You have to go back, do the experiment again, check what are all the possible values, compute the probabilities. Only then you can proceed and compute the values of mean. Now we have understood that if the distribution is a PMF, total probability is equal to 1. Now sometimes they will give you questions where they say it is a PMF, but one of the probability is missing. Now since you know that it is PMF, so they will specify this. So only if they have specified that it is a mass function, you can obtain the missing value. So you know that total probability should add up to 1. So equate this total probability to 1. You can estimate the missing value of it. Sometimes you could have only one missing probability. Sometimes you could have several or all missing probabilities, or all could be in terms of k. So I can give you a question like say k, 3k, 3k and k. So the total comes out to be 8k. So you are telling that since it is PMF, total P is equal to 1. Total P according to the given model is 8k. 8k is equal to 1 implies k is equal to 1 by 8, which is 0.125. So you are getting 0.125, 0.375, 0.375 and 0.125 back. So these are all some of the application level questions which also test your knowledge and understanding about the topic. The next case is a case where you cannot count the value of x, you cannot observe the discrete value of x. What best you can deal with the variable is that you can observe only the values in a certain range. Values in a certain range. Let's turn back again.